Hello and welcome to the Electrical Engineering Workshop, Lecture 2. So, in this lecture, we will cover what a diode is. A diode is an electrical component that allows the flow of current only in one direction. There is no resistance in that direction, but there is an infinite amount of resistance in the opposite direction. A diode also causes a voltage drop. When making a circuit with a diode, we always add a resistor in series to prevent short circuits because the diode has no resistance. Now we will do an example problem using a diode. In this problem, we want to find the current through the resistor. In order to do that, we use Kirchhoff's voltage law. The total voltage drop of the loop plus the voltage of the battery should be equal to 0. We know that the voltage drop for the resistor is equal to the resistance times the current based on Ohm's law, and that the voltage drop for the diode is 2 volts indicated in the diagram. Doing the math, we see that the current is 1 amp. This is the second example problem, and once again, we are looking for the current through the resistor. At first glance, we think that we can solve this problem in the same exact way that we solved the previous problem. However, if we look a little closer, we'll notice that the voltage drop of the diode is greater than the voltage of the battery. Thus, there is no current passing through the resistor. This is the third example problem, and once again, we are looking for the current through the resistor. At first glance, again, we think that we can solve this problem in the same way that we solved the first problem. It looks very similar to the first problem. However, the diode is pointed in the opposite direction than it should be, and therefore, there is no current through the loop. We will email you some problems so you can practice on your own time. This is an LED. I'm certain you have all heard of these before. They are a type of diode. The longer lead corresponds to the positive end, and the shorter lead corresponds to the negative end. Direction matters, as we saw in the last example. Now we are going to try and make an LED light up. Here we can see that we have built a simple circuit that contains a lit LED. The current travels from the positive side of the battery through a resistor, through the LED, through a jumper cable, and back into the negative side of the battery. If we flip the LED around, you can see that the LED will not light up. This is because the LED is a diode and current only flows in one direction through a diode. Here's a challenge. How do you think you can make another LED light up with no additional jumper wires? Here's the answer. Just add the new LED in parallel to the previous LED. Now let's learn about capacitors. Capacitors store electrical charge, and they consist of 2 conductive plates. Each plate accumulates charge. One plate becomes positively charged, and the other plate becomes negatively charged. We can think of a capacitor like a water bottle. We can fill up the water bottle, charging, and we can pour out the water bottle, discharging. Once a capacitor is charged, it can act like a battery. You might be wondering how capacitors get charged. Initially, uncharged capacitors act as normal wires. The more charged they become, the more the current decreases. Once the capacitor is fully charged, the current goes to 0. While discharging, a capacitor becomes a temporary battery until it loses all of its charge. The current will travel in the opposite direction compared to when the capacitor was charging. Now we are going to do a capacitor lab. Using only a capacitor battery, resistor, and LED, can you make the LED light up without directly lighting it up using the battery? We can put the capacitor and resistor in series and charge the capacitor. Once the capacitor is fully charged, we can remove the battery and replace it with an LED. Pay attention to the LED's direction and notice how the LED lights up. The LED will only light up for a short amount of time and will not be lit up after the capacitor is fully discharged. Inductors are almost always taught with capacitors. Inductors are basically the opposite of capacitors. They rely on magnetic fields to store current. They are fairly complicated, but you will learn more about them in high school physics. Thank you.